Okay, we are into the second part or the second half of this chapter on summation of series. Okay, if you guys have done that APGP um, chapter in your A level maths with a greater understanding or deeper learning, then you must be able to relate this chapter with that, because that is a basis of all this chapter. Do you remember in your GP you had the converging series? When do we have the converging series in GP? Yes.
R is less than 1. R is less than 1.
Your R is less than one. Okay. So basically, it's something like, for example, if your first term is A and you're going to multiply with something which is like, whose magnitude is less than one. So that is obviously anything whose magnitude is less than one. So it has to be a fraction. It can be 1 over 2, 1 over 3, or maybe 2 over 3. Any proper fraction would should always have a value which is less than 1. Okay, so that is what going to happen in these. If you look at this example over here, that is, he's asking for the sum of this series. Okay, so for example, if you put your R as 1 over here, okay, so you have 1 over 2. Okay, and then if you put your R as 2 over here, so there is going to be 1 over 6. And then you have, if you put your R as 3, so you see that this is going to be 1 over 20. I think this is 3. When you put this 2, this is 3 into 4, 12. 1, this is 2 into 3. Oh, sorry, this is not the first term. Okay, so this one is going to be 12. Okay, and the next one would be 1 over 20, and so on. So you see that there is a decreasing trend in it. Okay, and therefore if you keep on writing all these terms, so you see 1 over 6 and then 1 over 12 and 1 over 20, are these values decreasing or increasing?
Decreasing.
They are
Decreasing.
decreasing. So the larger is the denominator, the smaller is the value. So like there will be a time then this would be approximately like, I mean, a very, very small value leading up to 0. Okay. So we can say that this is a converging series over here. So how to find this converging series, especially when you have these rational functions over here. Okay. For this purpose, you have to be very good at writing the partial fractions. So one thing that would be needed to cover up this segment efficiently is that you should be very good at writing the partial fractions. So that will always be the first step where you write the given fraction. Okay, and then you will be writing the partial fractions for that segment. Okay, and after that you see that once you have written down the partial fractions, now here all process is done. So this expression, which was initially 1 over r plus 1 into r plus 2, that has now become 1 over r plus 1 and then minus 1 over r plus 2. Okay, so since the sum is from 1 to n, so how to handle this? You will start putting the values of r into it. Okay, so this would become 1 over 2 minus 1 over 3. Okay, this and then plus, then you put 2 into this is 1 over 3 minus 1 over 4, and then you put 3 into it, this is 1 over 4 minus 1 over 5. Okay, and then so on. So you have 1 over n plus 1 minus 1 over n plus 2. Okay, if I just expand this a bit more, you see this is going to be 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4, and then you have minus 1 over 5 and so on. Okay, I can write the second last over here as well. When, like, here your r is n, if I put r as n minus 1, so this would be minus 1 over n plus 1, and this would be 1 over n over here. Okay, 1 over n. So this is, let me write it as plus 1 over n minus 1 over n plus 1 plus 1 over n plus 1 minus 1 over n plus 2. If you look at this very carefully, then you will be able to notice that, like, all these terms are going to be cancelled out. Okay, so you will be left with this half from here, and then this minus 1 over n plus 2. So all this sum from 1 to n can be written as 1 over 2 minus 1 over n plus 2. Okay, so suppose you have to find the sum of the series from R1 to 10, suppose, okay, from 1 to 10. So you will put your n as 10 over here. So its value would be 1 over 2 minus 1 over 12. And you can find that, like, you can sum this up mentally, or you can find this with the calculator, okay? Mostly at the end of this, it is the question is asked that what is the value of this sum from R1 to N of this 1 over R plus 1 into R plus 2 when your N tends to infinity. Okay? So what would be this sum equal to when
1
your,
over 2.
yeah?
It would be 1 over 2.
Yeah. Why this would be 1 over 2?
Because when n is really big, then 1 over n plus 2 becomes 0. So you're left with 1 over 2.
Exactly. So this, its answer would be half. Okay, because when n tends to infinity, then to him, this becomes 0, and this will be half. Okay, so that is how you will be trying the questions from this exercise that we have right here in this exercise 3b, and I think that is the last exercise of this book. Okay, so that was the it from the recap of this second part of this summation of series. So this with the whole summation of series